Let us now solve these two problems together. Let us begin with question number 1. In nature, sulfur often appears in sulfide minerals, which contain the sulfide anion. Lead sulfide, PbS, is one example of such a mineral. Its unit cell is shown below, which is similar to the unit cell of sodium chloride. Given that the edge of the unit cell in PbS is 5.936 angstroms. Now, this symbol is called angstroms, and it literally means 1 times 10 to negative 10 meters. The question is that we should calculate the density of lead sulfide in grams per cubic centimeter. Before we begin to dig into this question, I want you to pause the video and take a careful look at the unit cell given to us. I need you to determine the empirical formula of PbS based on this unit cell. Let us now do it together. Let us begin with lead. If you look at the lead atoms, you will see that these ones that I am highlighting are on the edges. All of these highlighted lead are on the edges. And if you count all of them, you will end up with 12 lead atoms on the edges. So 12 lead atoms on the edges. So how many lead atoms will then be in the unit cell? That will be 12 multiplied by 1/4, which will work out to 3 lead atoms. Why 1/4? Because each edge of a unit cell is shared by 4 unit cells. There is one more lead atom here, and that lead atom is in the center of the unit cell. One lead atom in the center, that is one full atom. If you add all of the atoms of lead in the unit cell together, you have 4 lead atoms. Let us now begin with sulfur. If you look at the sulfur atoms, you will see that 8 of them are in the corners, in the 8 corners of the unit cell. So 8 sulfur atoms in the corners. That will work out to 1/8 times 8, which will be equal to 1 sulfur atom. Why 1/8? Because each corner of a unit cell is shared by 8 unit cells. If you look carefully, you will see that we also have other sulfur atoms on the 6 faces of the cube. So, 6 sulfur atoms on the faces. That will be equal to 1/2 times 6. Why 1/2? Because each face of a unit cell is shared by 2 unit cells, and that would work out to 3 sulfur. So we have a total of 4 sulfur atoms. Therefore, the empirical formula based on this structure given to us will be equal to empirical formula is equal to PB4S4, which will be PBS. But this is what we actually need, because in this unit cell we have 4 lead atoms and 4 sulfur atoms. Now remember that we are trying to find the density of the lead sulfide. So how do we go about finding the density? First, we need to remember that density is found from the ratio of the mass of a substance and the volume of the substance. So, to solve this problem, we need to calculate the mass of a unit cell, and then we need to calculate the volume of the unit cell. Let us begin with the calculation of the mass of 1 unit cell of PBS. We have 4 lead atoms in the unit cell. So, the mass of 4 lead atoms will be equal to 4 atoms of lead multiplied by 1 mole of lead atoms will have a mass of 207.2 grams. If you check your periodic table, a mole of lead will contain how many atoms? 1 mole will contain 6.022 times 10 to the power of 23 atoms of lead. And if you cross out the atoms and you cross out the moles, what you have remaining is the grams of lead. That will give us the mass of 4 atoms of lead. If you plug this into your calculators, you should get 1.3762 times 10 to the negative 21 grams of lead. Let us now move on to the mass of 4 atoms of sulfur. Mass of 4 sulfur atoms will be equal to, again, we have 4 atoms. 1 mole of sulfur will have a mass of 32.06 grams. And we know that 1 mole of any substance will contain 6.022 times 10 to the power of 23 atoms. So, if atoms cancel out and moles cancel out, what we end up with is the grams of sulfur. If you plug this into your calculator, you should get 2.1295 times 10 to negative 22 grams of sulfur. But in this question, we want to find the mass of the unit cell. And we have 4 atoms of lead and 4 atoms of sulfur. So we will need to add the mass of the 4 atoms of lead to the mass of the 4 atoms of sulfur. And if you do that, the total mass of the unit cell will be equal to 1.5892 times 10 to negative 21 grams. So we now know the mass. The next thing to find is the volume of the unit cell. To do that, we need to remember that the edge of the unit cell is given the length of the edge of the unit cell. Now, we know that volume of a cube will be equal to the length of the unit cell raised to power 3. So in this case, that will be equal to 5.936 times 10 to negative 10. Remember, angstroms means 10 to negative 10 meters raised to power 3. Let us convert to cubic centimeters. That will be equal to, multiplied by the conversion factor, 10 to negative 2 meters equals to 1 centimeter raised to power 3. Written like this, the cubic meters here will cancel out the cubic meters here. Again, why am I using 10 to negative 2? It is because centi literally means 10 to negative 2. If you plug this into your calculator, you should get the volume equals to 2.0916 times 10 to negative 22 cubic centimeter. Now we can calculate the density because we know the mass and we know the volume. So density will be equal to the mass, which we calculated as 1.5892 times 10 to negative 21 grams, divided by the volume, which we got as 2.0916 times 10 to negative 22 cubic centimeter. And if you put this into your calculator, you should get approximately 7.60 grams per cubic centimeter to 3 significant figures as the density of PBS. Now let us take a look at question number 2. Calcium metal crystallizes in a face-centered cubic unit cell, FCC unit cell. The density of the solid is 1.54 grams per cubic centimeter. We want to calculate the radius of a calcium atom. How can we perform this calculation? If we want to know the radius of the unit cell, we first would need to know the length of an edge of the unit cell. So the radius would be calculated from the length of the edge of the unit cell. And the length of the edge of the unit cell can be calculated from the volume of the unit cell. So the magic bullet here would be finding the volume. And how can we find the volume? We know the density. We know that calcium crystallizes in FCC arrangement. And we know that FCC arrangement will have 4 atoms per unit cell. We can calculate the mass of 4 atoms of calcium. Let us do that. So mass of 4 calcium atoms will be equal to 4 atoms multiplied by 40.08 gram for 1 mole of calcium multiplied by 1 mole of calcium will normally contain 6.022 times 10 to the power of 23 atoms. Atoms will cancel out, moles will cancel out. So we are left with grams as the only unit. If you plug these numbers into your calculator, you will get mass of the unit cell is equal to 2.6622 times 10 to negative 22 grams. Now, we know the mass, we know the density, we know that density is equal to mass of a substance divided by its volume. If you rearrange this will give you volume will be equal to mass divided by density. So let us plug in the values for the mass and the density. So the volume of the unit cell will be equal to 2.6622 times 10 to negative 22 grams, which is the mass of the unit cell, divided by the density of the unit cell, which was given to us, which is 1.54 grams per cubic centimeter. And if you put these numbers into your calculator, you should get volume equals to 1.7287 times 10 to negative 22 cubic centimeter. Now we know the volume. We can now use the volume to find the length of an edge of the unit cell. We know that cubic of the length of an edge will be equal to volume. So let us plug in the value of volume, 1.7287 times 10 to negative 22 cubic centimeter. And if you find the cube root of both sides, you will see that the length of an edge of the unit cell will be cube root of 1.7287 times 10 to negative 22 cubic centimeter. That should give you a value of 5.57 0.069 times 10 to negative 8 centimeter. But we are dealing with FCC cubic unit cell, which means that the relationship between the length of an edge of the unit cell and the radius is 2 root 2 multiplied by r. If you rearrange this, r will be equal to L divided by 2 root 2. Plug in the values. 5.57069 times 10 to negative 8 centimeter divided by 2 root 2 will be equal to r. And if you plug these numbers into your calculator, you will find that r equals to 1.97 times 10 to negative 10 meters if you round to 3 significant figures. Now, you can also write this as 1.97 angstroms.